Hi everyone, my name is Rena Pope and I will be doing a lesson on derivatives. First, this one's going to be an introduction video on derivatives. So first we need to define derivatives. A derivative I define as an instantaneous rate of change at any given point. And so this definition sounds a lot like a slope, where we know that m equals the change in y over the change in x. And this is a really easy thing for us to do whenever we have linear functions. But once the graph gets curved, it's a little more complicated. So with this curved graph, we can't find the slope at any given point because the slope changes. But if we were to try to find the slope, we would still do the same thing, where we have the change in y over the change in x, where this is 0.1 and this is 0.2. And so, finding the slope, we would do the same thing. We would do y2 minus y1 over x2 minus x1. But to find one at a specific point, we want this part, the delta x, to be as small as possible. So I'm going to give delta x a letter value. We're going to call it h. And so to find the slope, we want h to be as close to 0 as possible. And in math, we call that a limit. So we're going to say the limit as h approaches 0, as y2, which is f of x plus h, that's y2, minus y1, which is f of x, all over h. And so this is our mathematical definition of a derivative. And as you can see, it looks a lot like our slope because derivative is a rate of change. So now let's do a couple of examples to practice this. First, we're going to try f of x equals 2x plus 4. So every time, so we know the limit as h approaches 0 of f of x plus h minus f of x over h. And so that's going to be the limit as h approaches 0. Every time we see an x in our equation, we're going to plug in x plus h. So 2 times x plus h plus 4 minus 2x plus 4 over h. And then we're going to continue to solve. We don't want h on the denominator because otherwise we'll have an undefined function. So 2x plus 2h plus 4 minus 2x minus 4 over h. Now we can start crossing things out. So negative 4 and 4 cancel out, negative 2x and 2x cancel out, and we have an h on the top and an h on the bottom. So we can cancel our h's out too. So that leaves us with f prime of x equaling 2. So that tells us that the rate of change at any given point on this function is 2, which makes sense because this is a linear function, which means the slope isn't changing. So the slope is constant. It's always 2. So let's try a different one this time. F of x equals x squared plus 4x minus 6. So we're going to start with our definition. And now, as before, every time we see an x, we're going to plug in x plus h. So this equals the limit as h approaches 0 of x plus h squared plus 4 times x plus h minus 6. And that's going to be minus x squared plus 4x minus 6. All of that is over h. And so we're going to keep going. We're going to solve and try to get rid of our h on the bottom, on our denominator. So this is x squared plus 2xh plus h squared plus 4x plus 4h minus 6 minus x squared minus 4h plus 6, all over h. So now we can start canceling things out again. Our negative 6 are going to cancel. Negative 4x, positive 4x, and our x squareds will cancel. So we're left with the limit as h approaches 0 of 2xh plus h squared plus 4h over h. From there, we can factor out an h, so that'll be h times 2x plus h plus 4, and then our h's will cancel. So we're left with 2x plus h plus 4. We can plug in 0, so we're left with f prime of x equals 2x plus 4. So the slope, the rate of change at any given point can be defined by the function 2x plus 4. So if we were to say what's the slope when x equals 4, we can plug it in. So 2 times 4 is 4. No, 2 times 4 is 8, plus 4 is 12. So this is the basic definition of a derivative.